Thanks for the introduction, Hui, and I really appreciate Hui and the marketing section of ASA to organize this webinar to make kind of like a statistician in general to be more familiar with data science and the big data platform. And welcome everyone. Good afternoon. And the topic for today is Big Data Cloud Platform in Industry for Data Scientists. The industry is actually across tech industry as well as the traditional industry that traditionally is not the tech sectors such as retail, transportation, and other manufacturing and other industries in general. So before we go to the detail, I'd like to kind of like introduce myself a little bit. By training, I'm a statistician. I got my Ph.D. in statistics from Iowa State University at year 2000. After that, my first two jobs are primarily statistician at the GE Global Research Center and SAS Institute. From a few years ago, I joined Wal-Mart as a data scientist. And more recently, I moved to Seattle as a senior data scientist in one of Amazon's data science team. So basically, I more or less transferred myself from a traditional statistician in a traditional industry and then to be a data scientist in a tech company. And I'd like to share my journey of how to become a successful data scientist with statistics background in general. And as Hui's main audience probably is from the marketing section in ASA, so very likely you and me share a very similar background. By training, we're statistician, but in the job market right now, data scientist has increased quite a lot in the past few years. And it is really good career path for statisticians in general. So this is a brief outline of this webinar. First, I'm going to illustrate the challenges for big data modeling, and then introduce a cloud environment where those challenges actually can be partially overcome. And the third part is data warehouse and database, which is essential for a data scientist, but for a statistician in general, we may not have an exposure by formal training. And then followed by a brief summary. Okay, first, challenges of big data modeling, and it is actually opportunity for a statistician in general. So first, let me walk through some of the different practice between statistician and data scientist. Not always kind of like that difference between statistician and data scientist. Is more like from a traditional point of view for statistician and from a data scientist point of view of how people usually do things slightly differently. For example, for statistician in general, data is somehow given to us in a text file, flat file, CSV file, or Excel file. But for a data scientist, data is rarely given, and you have to get your data from some sort of database system. And sometimes you have to grab your data from the internet. And for statistician, we usually have a good background in modeling, and sometimes we focus on modeling. For data scientists, many of them actually do not have a formal training in statistical model, and usually we focus more on the results. For statistician, usually we train the model and then feed the data to the model. This is what I call a bring data to model. But in reality, the model itself is a relatively easy part. How to integrate the model to the data become very challenging. And from a data scientist point of view, it is more like bring model. So data scientists usually centralize their idea to the data, where statisticians usually focus on the idea, probably on the model. So here's one simple example that I can summarize that later. Let me finish the last one. For a statistician, we usually are very further away from the production system. And the data is given, and we're using our own laptop to train the model, and then maybe at the end, create a report. But for data scientists, they usually do the same, but that's not the end of the story. And usually, for data scientists, there will be more concern about how to bring the model to the production system such that there will be automatic decision-making process. I'm going to actually can tell a story of the difference between statistician and data scientist using time series forecast. So we know for time series forecast, there are exponential smoothing, ARIMA models, and a few different kind of families of models. From a statistician point of view, usually you have a few time series data, and you can tweak your model, transform your data to match the assumptions, and then fit your model and have your result. From a data scientist point of view, sometimes you have to fit time series models for millions of time series data, and you have to refresh the time series model every week, for example. So the starting point are all the same. It's time series forecast, but for data scientists, usually the scalability become more concerns. So we cannot spend a lot of time for each data set, for each model. It has to be automatic, and it has to be embedded in the production system such that once the new data comes in, the forecast will be done relatively automatically without too much human intervention. So that is kind of one example. It's my own experience, actually. When I was in Wal-Mart, I have to solve the problem of doing time series forecast for 450 million items product and refresh the forecast every week. Okay, once we know the difference, hey, yeah. Hui, can you repeat it? Can you repeat the question? Yeah. The questions are pretty much the same, but from a data science point of view, usually in addition to what statisticians usually solve, for a statistician, we are a good consultant, and we answer questions, we create a report, we create dashboard, but from data science point of view, sometimes we have to take into account scalability, implementation to the production system, and how to automatically refresh the model when the new data comes in. So I think the last 3 points from a statistician point of view, we care a little bit less. But for data scientists, sometimes we need to focus more. Hui, can you speak to your phone a little bit closer? Because I can. Oh, experimental design. Actually, for experimental design, it is very similar. It's very similar situation as the time series example. For experimental design, usually there are 100,000 or even 10,000 of different kind of design experiment going on simultaneously for tech companies. So a lot of those is behind the scenes. We may not, the user may not see, and sometimes the user actually can see it. Like for example, change the color and the font for some of those display of the product on the website, and some are actually behind the scenes. So for experimental design, there are indeed a lot of the scalability and automation is also a relatively automatic process. And for example, how to automatically find the control and experimental units, and based on the properties that we know. Sometimes the properties for that specific unit, there could be hundreds of different kind of attributes to consider. Hui, can you repeat the question? Yeah. Yes. So sometimes in a experimental design, in an online environment, sometimes you do not know exactly what actually going on. There could be multiple experiments around the same subject. So one of the advantage for online tech companies, they have a pretty large customer base. So they can actually create a small universe where they are not going to be interact with each other. And oftentimes there are the analysis that need to be done to how to separate those control and experiments using the attributes that we want to control and some of the attributes we want to do the experiments. So that is actually some good questions around how to do a better online design experiments. But design experiments generally is used across all tech companies to kind of like test the hypothesis. And in tech companies, usually it is data-driven. So the data is collected sometimes in real time. So there are three pillars of successful knowledge for successful data science. Maybe you saw that some similar graph in different talks or presentations. So there are analytics knowledge, domain knowledge, and the big data management and IT skill. And for statistician, we are pretty good at analytical knowledge and tool set. We're pretty good at domain knowledge and collaboration because many of us actually have a lot of consulting work in the past. And one of the area that we need to learn a little more to be a successful data scientist is the big data management and IT skill, such as the big data infrastructure and some of the database and data retrieval skills, some of the software like Hadoop SQL, and Spark, and a few others. And the good news is we already familiar with 2 out of 3. And the most difficult part for other people to learn is the modeling detail, statistical models, which we already know under the hood mechanism. And the even better news is with the cloud environment and the barriers for the data management and IT skill actually is lower and lower. So, which means there's indeed actually opportunities for us like statisticians to be successful data scientists. And especially the big data infrastructure, integration, automation, execution, those 3 used to be the barriers for statisticians to be part of the data science community. Those are partially solved by the cloud platform. And at the end of the day, we are actually using data to get information and to gain knowledge, and then to have some insight. At the end of the day, it will be automatic decision and actions, different from what we do as a statistician. Okay, now let's come to the second part, the cloud environment. As I just mentioned, for the cloud environment, it lower the barrier for a statistician to be a successful data scientist. Before we go to the detail, let's look at it. What happens for statistics in general? So you may be very familiar with this history of statistician in America. So at the beginning, 1839, the ASA was established. At that time, the data is usually in pieces of paper. And 1934, there's the first statistical laboratory in a U.S. university. It's from Iowa State University, and data in tapes or punched cards. And now, like 2010, the data in one computer's disk or memory. Now we have the data science revolution. Now at around 2017, the data is in the cloud. The reason for where the data exists is due to the size of the data. When the size of the data goes larger and larger, it cannot be fit into one computer's disk or memory, even for the most powerful computer we have for now. So there's the trend of data to be in the cloud. And along with how the data has been collected and analyzed, it also has a high correlation with the Industrial Revolution. And first, we have the Industrial Revolution, and we're using machines and factories that change the way of how humans live with efficient productivity. At that time, the data probably is way early kilobytes. And then there's the internet revolution, information technology that changes how humans communicate and interact. We have the data in the terabytes of data for companies to analyze. And then we have the Internet of Things age, where everything will be connected and automatically create a lot of data, and there will be automatic analytical decision to optimize how machine work and communicate with human to utilize the full capability. So that's the terabytes or even more data will be created from machine-machine communication, machine-human communication, and human-human communication. That's great opportunity because whenever there's data and we need to analyze the data, And statistician in general has been analyzing data for centuries. And we know the mechanism behind all the models. And we are excellent candidate for data scientist. And one of the techniques or skills we lack usually are the data management and some of the big data infrastructure and programming related. Is the cloud environment. There are a lot of advantages to lower the barrier. And the data in the cloud, because one computer cannot feed all the data that is available, so there's a scalability. And for the cloud providers, they solve the scalability and maintenance issue, and it is kind of behind the scenes for users. And we usually do not actually technically do the scalability and the maintenance. So the cloud provider is going to solve that. Like AWS is one of the cloud provider, and many websites are actually using AWS as their hardware and their platform. So even for like there's many websites using AWS as the infrastructure. So they do not need to take care of anything for the scalability and the maintenance. And then because of this cloud environment, massive data set is easier to get for analysis. And sometimes you do not need to get the data to your computer. You can use the cloud environment to analyze all the data that is available in the cloud. And efficient model training on larger amount of data become possible because of this big data infrastructure. And also for the cloud environment, model deployment to production environment is also much easier. And model refreshment becomes relatively automatic tasks. So for all the disadvantage that we saw in the past few slides, the cloud environment actually provide a very good solution. And here is a few cloud environment that provides providers for learning purpose. And the first one that I use, the Databricks Community Edition, which is also managed by the inventor of Spark. So it has a very good integration of Spark with R and Python. So it's a good starting point for a cloud environment. And from Databricks Community Edition, you can create a cluster of multiple cores with certain memory seconds. And then you can run your job in a cluster, Hadoop cluster with Spark capability in no time. So you do not need to have a hardware or software or operating system to have a cloud environment. It is just one click away. You can create your cloud environment. And this is actually a good training website. For training purpose, you can create and do some learning and to get familiar with the cloud environment through Databricks Community Edition. On the other hand, we have the Amazon AWS, Microsoft Azure, and Google Cloud Platform. They are more like full stack cloud environment, which provide much more capability than Databricks Community Edition, and they do have free trial as well. But I recommend you start it with the Databricks Community Edition, which is specially tailored for data scientists, and it is very easy to start. And I have two short videos for how to use Databricks Community Edition, which actually can run R and Python, SQL, and Scala. notebook fashion, and because we do not have too much time for today, and you can actually go to the YouTube, my channel, to watch those 2 short videos. After you watch that, you will be able to create your own account and create your own Spark cluster and run some machine learning algorithm in a cloud environment. And it is like a learning environment, which means in reality, the data will be much larger, the cluster will be much larger, but the code and algorithm you are using for the actual problem will be very similar. So it's a really good learning environment for anyone who wants to learn how to leverage cloud environment for their everyday work. And also, there's also a trend for the traditional companies. They're going to have either a public, they're either using a public cloud or a private cloud environment for the enterprise applications. And very likely, they already created the kind of like Spark environment with R or Python interface such that you can play with your data. And before we go to the next section, which is database management, I'd like to show about what is the Databricks Community Edition will looks like. So this is the Databricks Community Edition, which is completely free. You can apply account right away. So we create a notebook. We can try here. For example, text test. It can be in R or Python, SQL, or Scala, and then you can create a notebook. You can run your command here. The typical R command can be run here, and you can use the Spark library for you to run some machine learning algorithm on a big data environment. And here, the data in a production environment, the data is already, very likely the data is already in the cloud environment, which usually means if you are using a Hadoop basic infrastructure, maybe the data is in a Hive tables. If you are using, like for example, other platform, the data is already in some sort of database environment. And for this Databricks Community Edition, it provided some sample data for you to play with, which is already there. And also, you can upload your own data to Databricks Community Edition to play with. And I'm going to actually show how to create a cluster, like cluster 1. And then there are different kind of like clusters you can create, like based on Hadoop 1, Hadoop 2, and GPU, and there's all different kind of ways you can create your cluster, specific cluster. This is let's use kind of more or less the default one. Then you put in the for this cluster, we're going to get a free 6 GB of memory, and then there are some configuration options you can play with. But we can do create a cluster. Then within a few seconds, your cluster will be created, which means it is a a cluster in the cloud environment where you can use right away. So this one, yep, it is already created. So for in this community edition, there's kind of like a different kind of tables. You can upload your own data to a particular table, and you can run your jobs and using the notebook we just created. I have a more detail in the two videos to show you how to use Databricks Community Edition. And there's also a very nice open core, I think it's in a EDX. There's a pretty good introduction course on how to use Databricks Community Edition for machine learning. That's a very nice one if you like to get familiar with it. And also, I would like to show you one blog that is playing with 80 million Amazon product review ratings using Apache Spark. This is written by Max, and he provided a notebook how to use this Spark packages to model a fairly large data. I think for this one, the Amazon product review is around maybe 5 gigabytes of data. And if you use traditional R packages, it actually may take a very long time to do some analysis. So this is a good example. You can look at it, and all the data and the code are included in this blog. You can actually play with it. In a local version of the Spark, you can choose to install in your own computer. You can try this cluster version, and initially it may have some learning curve, but it's all straightforward. Once you get familiar, it is just like using your RStudio's notebook to do analysis. The only difference is it is in the cloud environment. Everything is saved in the cloud environment. Every data, every code is in the cloud environment. And you do not need to worry about anything of this computation environment is down or not, or there's some memory limitation. In general, for a cloud environment, you can always increase your memory and hard disk and all the specifications according to your problem size. So again, this is a good blog. You can look at it. And this is 2 short videos that I put on the YouTube. You can look at it as well, especially you are very new to the cloud environment. You're very new to Databricks Community Edition. And also, Databricks Community Edition can run R, Python, SQL, and Scala in one environment. So that's very convenient. So Hui, any questions for this section? So it's there are some packages that actually wrapped all the not all, but most of the Spark functions. So you can actually, once you read in this package, let me go to the, then you can, once you have the package in this particular example, you can use a lot of the Spark functions within your R code. So this one provide a some very good initial introduction of how to use the Spark related functions there. So of course there will be some Spark specific functions within that packages, like Spark config, for example, is going to config how your Spark environment is going to work. But other than that, it's part of our environment. Like for example, they're reading the Spark read CSV file to utilize the Spark infrastructure to reading the file and distribute in a way that it will be more efficient to do analytics. So you can see that if you use R, you can see it is very familiar to the typical R code that you see in the past. Sure. So Hui just mentioned be heard by the audience. So just a moment ago, I answered one of the questions that in the Spark in R, do we need to learn the Spark command? And the answer is there are some Spark specific R command packages and functions has created. So so this is a good example. You can see the similar typical R functions you use. Okay, Hui just mentioned another question is what's the most popular machine learning models that I have know so far. So the most popular machine learning models, I think, is based on my observation, where the Kaggle competition, etc., all those information is kind of like a random forest family, is one of the very popular one, as it is also very flexible and it deals with overfitting relatively good, and it is usually kind of can be applied to all different kind of data set. So it is very popular one. Okay, all right. Let's go to the next section, which is the database management. Database management is one of the key elements that many statisticians actually do not have at this stage, but they're really easy to learn. So you may ask why database management? From what we learned just a moment ago, the data is typically beyond a computer's memory or hard disk, and a database management system is needed to manage all those data. But even the data can be fed into one computer's hard disk or memory. Database management system provide a much better way to manage data, such as the ETL, extract, transform, load jobs, as well as ensure data integrity. And also, oftentimes in the production system, all the data is actually in some sort of database system to ensure real-time read, write, and load. For example, for an online, the real-time transactions, how many products on hand, and when a customer purchases 5, and we need in real time to reduce the on-hand value by 5, and a lot of details that happen in real time. The database system actually have a good management on the data and the change of the data. And the entire system is very complicated. need to consider a lot of different kind of things. For example, there are multiple customers look at the same product, etc. But the SQL standards make it easy to deal with different database management system. Modern big data infrastructure, like Hadoop system, we have a Hive. It's kind of like a database, but it's leveraged the distributed clusters. And a lot of the technical details are behind the scenes to make sure the database system, management system works. From a user point of view, the SQL structure the core language become the interface for us to interact with database. As I mentioned at the beginning, in an enterprise level, all the data, nearly all the data are in some sort of database system. So even though there are flat files floating around, but the most important data are actually in some sort of database system. Know how to extract some of the data out is really the first step. You become a data scientist, because in the enterprise environment, a data scientist is supposed to get his or her data by himself or herself. And usually from a statistician point of view, traditional statistics department does not provide data management courses or training, but it is really simple. So from a database point of view, we have database, and within database, there are some tables. Within each table, there are rows and columns. It's called records and fields. And at the very end, it is just one data cell. It's one row, one column intersection. This is one piece of data. That's very basic elements. And there are a lot of mechanisms within the database management system for fast data retrieval and analytic purpose, like a key, petition, index. All those makes data retrieval and analytics much faster on a big data platform. There are all different kind of database system, like a row-oriented, column-oriented database. There's a database in hard disk or in-memory database. There are distributed and highly parallel, massive parallel database. But a lot of those work is done behind the scenes. And from a user point of view, we can focus on writing SQLs as well as get familiar with what is the key, petition, index mechanism to retrieve the data faster and to do the analytics faster. And sometimes, which means like multiple terabytes of data that is available in a database. And for the main SQL functions, SQL is like structured core language, simple data retrieval using select statement, combine data from multiple tables using join and uni, and sort data using order by, aggregate data using group by, subset selection using where and having, and changing data using update, insert, and delete. And so that's pretty much it is, all the basic SQL related functions. So a few videos that describe the basic SQL functions through my YouTube channel. You can actually, if you have zero background on database management, zero background on SQL, you can quickly watch those videos to get familiar with the SQL environment. And there are like a W3 kind of college. There's a SQL course which you can actually run your SQL online. You do not even need to install anything. And also from the Databricks Community Edition, you can also run SQL when you have multiple tables in your environment. So, which means you can learn SQL without install any software. But if you want, you can also install some open source database management system like MySQL Workbench, which was used as the platform for my YouTube videos. But the summary for SQL is it is very easy to learn, and a lot of the technical details are behind the scenes. What you need to be familiar is just the SQL functions and statements. And there are actually not many. So in this slide, it's pretty much cover 90% possibilities. So any questions on the database management system, Hui? Okay, good. Section is Linux system command. So this is another element that some theoretical statisticians lack, but it is really easy to start as well. And if you are in a biostatistics or computational statistics, you're already very familiar with the operating system. But if you're more or less in the social or theoretical statistics related area, you may actually have a much exposure on the Linux operating system. But again, it is really easy to start, and you can learn it very quickly. People may ask, we have all different kind of operating system, why the Linux operating system is needed for a data science career. It's because most production system and big data system requires Linux operating system knowledge. It is built on top of that. And it is a multiple user system that allow many users to use at the same time and high availability that the system can run days or months without restart or maintenance. It is really easy to start and obtain the basic knowledge for everyday usage. And that's actually what we need at this stage. From a statistician point of view, we just need a basic knowledge for everyday usage. And also it is indeed take time to be an expert in using it, but it's really easy to start. And that's pretty much the few areas that I think from a statistician point of view to be successful data scientist that we need to get more exposure. And big data modeling is challenging for statistician in data retrieval, model scalability, and model implementation and integration. Statisticians do have the advantage of in-depth understanding of the models and can go way beyond just calling functions from the packages. You may actually know that a lot of the data scientists that in the market, actually what they can do is just calling functions from packages and with some of the database knowledge. And that's actually a lot of the data scientists do. And I will not say they're successful data scientists, but they get a seat in a data science kind of career. And from a statistician point of view, we do have the advantage of in-depth understanding of all the models, and we can go beyond just calling functions from packages. That's one of the biggest advantage for statistician. And for people who has database management background or some programming background, if they do not have the in-depth understanding of the models, it is very difficult for them to learn the in-depth understanding for the models. And for statistician, the barriers we just mentioned, the cloud environment actually lower the barrier for us to become successful data scientist. So it is really encouraging for all statisticians from the traditional education in a statistics department, and with a little bit more knowledge in the cloud environment and database management, you actually open a much broader career path as a data scientist. So that is all for today. Thanks for Hui's effort to organize this webinar. And we have a few minutes left. I can answer a few more questions if you have. And for any other questions, you can reach to me later by using the email that I show in the PowerPoint. Yes, for the cloud environment, the Databricks Community Edition is a good starting point. And there are a open course for how to use Databricks Community Edition for machine learning. I think it's either in the EDX or Coursera. You can actually search around. Also, in my YouTube channel, I have a few videos of how to set up the Databricks Community Edition and how to create a cluster and how to create one notebook. So you can also watch that video as well. But the online open course is a very helpful one. Also, in one of the blog that I just showed, it gave us some feeling of how a notebook with Spark looks like. So once you are familiar with the terminology and the environment, the application is actually endless. You can, once you have the data in the right format, you can apply all different kind of applications. That's for the cloud environment. Databricks Community Edition is a really good starting point for personal learning purpose. And for the database management, as I mentioned, database management is really a simple topic for statisticians to get more familiar. And I do have in my YouTube channel, I do have around 15 videos, each between 15 to 30 minutes to introduce all different concepts about database. And you can actually watch that video as well, and also use the textbook that I used in that videos to get familiar with database management. And database management, especially how to write SQL code to retrieve data, is really the first step as a data scientist. Because as I mentioned, in the enterprise environment as data scientist, you are supposed to get your own data. So nobody's, hand you a flat file, say that's your data and work on it. It's not going to happen. So how to retrieve the data and how to join the data in a format that model can consume is the first step. It is also a lot of time-consuming step as well. If you are in an enterprise environment already, you may know that within the database, there are all different kind of database, there are all different kind of tables, there's all different kind of database management system. But at the end of the day, to get the data, you're going to use SQL in most cases. It is very easy to learn. The second question is deep learning is how to apply it to industry, and deep learning become a very popular topics, and majority of the application is still image analysis and recognition, and maybe voice recognition. So those are the two major areas, and but on top of that, there's some specific areas. The different teams actually using deep learning to try to show different kind of values, like the AlphaGo competition. Um, but how to make deep learning really a general methodology for general business problem, there's still a very long way to go. The question is, do you think data scientists, the demand for data scientists is going to increase, or it is already at the peak? So my opinion is, as the data is always increasing, there's a increasing trend for people to do related analysis, whether it is called a statistician or data scientist or artificial intelligence engineer. No matter how it is called, there are definitely increased trend on people can analyze the data and then bring value to the business, and also create automatic decision-making process. So I believe the data scientists or other names that are doing the same work is going to be expanding quite dramatically in the next few years, next decades or so. So we're away from the peak, because it started from tech companies, but it's not going to end at tech companies. It's going to spread to all traditional sectors, like manufacturing, pharmaceutical, retail, transportation, energy. Whenever you have data, there's always ways to utilize your data to create value. The create value can be reduce cost, or create more values. Like you can have more customer. Based on the customer analysis, you can provide personalized service. Also, one of the biggest area will be the Internet of Things, where machine and machine connect with each other, and how those data can be used to make an automatic decision will be a very dynamic area that is going to need a lot of data science related positions. Yeah, I'm very optimistic that the number of openings in data science related area, or no matter how it's going to be called, but people with the capability to analyze data, especially the increased amount of data that we see every day, is going to be increased. Yeah, it depends on the structure data given. So I remember one of the I think one of the joke that many years ago, that the structure, the relational database is going to go away. but we see there's more and more different kind of applications that is related to the relational database. And there are actually more relational database has been created. Like for example, in the historically, the database are like a row-based database, so the data are stored in a row-wise fashion. And recently, it's not actually that recently, in a few years ago, people realized for analytical purpose, how about we actually use a column wise database, so the data are stored in column. And the advantage for that definitely is a lot of analytics actually require operation on the whole column. So if you store your data in the same place with the same data type, and the computation will be much faster than a row-based database. So there are cases where you need real-time response and much faster than some of those other database will be better choice. And definitely it's going to depend on the application and your data type. But at this stage, at the enterprise level, the relational database is still dominating for the data storage. And because most of the data that people can do the analysis is still numbers and text, which is usually the two major data type in a relational database. Yes, that's right. Hui just mentioned structured database is still the major one, but there are definitely unstructured data available, and they are stored in some sort of database format. And when we actually have a good way to analyze this data and to extract the value from that data, and then they will have a lot of applications. But for the future, the relational database is still going to be a backbone for the use of data for a little while for the enterprise environment. Yes, the question is about, are there any big difference between the data scientist team in a tech company and a traditional company? And because I have the opportunity to be in a traditional company as well as a tech company, and the answer is yes, there are some difference, and primarily is from the infrastructure point of view. For the tech company, actually, it is usually has a better in terms of their infrastructure, how to retrieve the data and how to implement the model. But there are a lot of similarities as well. For example, for both the tech company and the traditional company, data scientists usually work very closely with the data engineering team. So there are data scientists and data engineers. Sometimes they're in the same team. Data engineers, they have more exposure to the production system, and they can set up the pipeline much faster. And data scientists are closer to the and try to extract value from the modern data. Another difference, because like tech companies like Amazon, with the very basic product is built by software developers. So software developers play a key role in tech companies, And software developers, data engineer, and data scientists all work together to add additional value using data and analytics. And for traditional companies, the business model are built upon uh, um, the historical development. So there will be more technical debt in a traditional company, their infrastructure or database system, and or how the model is going to be implemented into the production environment. But in general, the data scientist team are very similar across traditional company and um, tech companies. And also because of the cloud environment, the traditional companies are trying to leverage the cloud environment to release this kind of technical debt they accumulated in the past 20, 30 years. So that's actually good news. In the near future, the tech companies, they're going to use the cloud environment. And on the other hand, they provide the cloud environment as infrastructure to a traditional company. And the traditional company is going to leverage the cloud environment to kind of like more efficiently transit their data scientist team from a more traditional environment into the cloud environment. So so in summary, yeah, there are some difference, but the majority of the work are actually very similar. Yeah. And the requirements are also very similar as well. And in the future, the cloud is going to dominate the data and analytics platform. Requirement will be pretty much the same. And also for the traditional companies, for each company, they have their own business models and the business area. There's retail business, and GE is a manufacturing business, but it's more like towards a service business. So for traditional companies, if you have some background about the particular business model, and in addition to your analytical background, that is actually a plus. Because if you know the business model, if you have already done consulting work in that particular business, then you know how the business runs. And then with your analytical background, you can be a very good fit to that company. Thank you for dialing in today for this webinar, and I really appreciate the way to provide the opportunity for me to share some of my own experience that I learned as a data scientist, but I'm also a traditional statistician, and then hopefully we can learn together and to kind of like guide more statisticians who want to be a data scientist and to be a successful data scientist.